This is the lecture for section 7.6, Solving Equations with Rational Expressions for Math 1335. All right, I will not be doing any editing in these videos, so if I make a mistake, I'll just try to go back and fix it, and we'll go from there. All right, example 1 says identify each of the following as an expression or an equation, then simplify the expression or solve the equation. All right, so we know that an equation has an equal sign and an expression does not. So if we look at part A, it does not have an equal sign, so this is an expression. And we're going to simplify it. All right, so whenever we subtract fractions with different denominators, first we find the LCD. And the LCD for 4 and 3 is 12. So I'm going to multiply the first fraction by 3, or 3 over 3, and multiply the other fraction by 4, or 4 over 4. All right, so multiply straight across and get 9 over 12x minus 8 over 12x. Combine like terms and get 1 over 12x. All right, part B has an equal sign, so we know that this is an equation. All right, to solve an equation with fractions, I believe we've talked about this before. We do death by LCD, where you kill the fractions by multiplying every single term by the LCD. So the LCD for 4, 3, and 2 is 12. So I'm going to go through and multiply each term by 12. All right, and then simplify. So 4 goes into 12 3 times, 3 goes into 12 4 times, 2 goes into 12 6 times, 3 times 3, so that would be 9x minus 2 times 4, that'll be 8x equals 6. So now we have an equation that does not have fractions, and we can solve it. 9x minus 8x is x, so x is equal to 6. I believe we've done this in the past where our answers are in a solution set, which is just the curly braces, and the solution set is 6. All right, if you wanted to check this, you could plug it back in, plug 6 back in for x and see if you can verify it. All right, example 2, it says to solve and check the solution. So I will actually check this one. So again, whenever you have fractions in your equation, you want to multiply every term by the LCD. And again, the LCD for 3 and 4 is 12. So just go through and multiply every term by 12, even the terms that are not fractions. All right, then simplify. 3 goes into 12 4 times, 4 into 12 3 times. So now we have 4x plus 3x equals 120 plus 12x. Combine like terms on the left side. 7x equals 120 plus 12x. Subtract 12x. And you get negative 5x is equal to 120. Divide both sides by negative 5. You get x is equal to negative 24. All right, so the solution set is negative 24. And let's check this one. So you're going to plug in negative 24 everywhere you have x in the original equation. So that's negative 24 over 3 plus negative 24 over 4 equals 10 plus negative 24. All right, simplify the left side. That'll be negative 8 plus a negative 6 is equal to 10 plus a negative 24. Negative 8 plus negative 6 is negative 14. And 10 plus negative 24 is also negative 14. So it checks. All right, example 3, same thing. We want to get rid of the fractions, death by LCD, and the LCD for 2 and 3 is 6. So you'll multiply every term by 6, and be sure to treat this p minus 1 as a quantity. All right, so simplify, that's 3, that's 2. So 3p minus 2 times the quantity p minus 1 is equal to 6. Distribute 3p minus 2p plus 2 equals 6. I'll combine like terms on the left side, so that'll be p plus 2 equals 6, and subtract 2 from both sides. So p is equal to 4. The solution set is 4. All right, now we have rational equations. We have variables in the denominator, so we have to treat these a little different because we don't want to end up with division by 0. So looking at the denominator, I have x minus 2. If x were 2, 2 minus 2 is 0. So we know we can actually just make a mental note that when we solve this, x cannot equal 2. So the LCD is x minus 2, and we know that x cannot equal 2. So let's go ahead and solve it by multiplying every term by the LCD. And of course, x minus 2 would cancel out. So that's x is equal to 2 plus 2 times the quantity x minus 2. And distribute, x is equal to 2 plus 2x minus 4. Combine like terms on the right side. X is equal to negative 2 plus 2x. Subtract 2x. And get negative x is equal to negative 2. And if you divide both sides by negative 1, you get x is equal to 2. All right, we said that x cannot equal 2 because if it's 2, we get division by 0. So that means we have to throw this solution out, and there is no solution. All right, so you can either say no solution, you can draw a solution set with nothing in it, that's an empty set, or a circle with a line through it, that's called the null symbol. And I'm not sure which way you'll see it on your test, but it'll be one of the 3 ways, so just know that that is how you write no solution. All right, so now we're doing the same thing, but this time we'll have to factor the denominators first so that we can figure out the LCD. So let's first rewrite this with factored denominators. We have 2 times x times the quantity x minus 1 is equal to 1 over x minus 1, x plus 1. That's the difference of 2 squares. So the LCD is x minus 1, and x plus 1. Multiply each term by the LCD. And with this one, the x and x minus 1 will cancel out. With this one, x minus 1, x plus 1 will cancel out. So that's 2 times the quantity x plus 1 is equal to x, because 1 times x is x. Distribute 2x plus 2 equals x. Subtract 2x. So 2 is equal to negative x. And if you divide both sides by negative 1, you get x is equal to negative 2. Okay, so let's go back and look at the LCD and see what values x cannot equal. Well, we know x can't equal 0. X can't equal 1 because 1 minus 1 would be 0. And x can't equal negative 1 because negative 1 plus 1 is 0. So since we did not get any of those values, the solution set is negative 2.